Hi everyone, we're starting the second lesson on functions and relations, and what we're going to be looking at today is we're going to be looking at interval notation. So we'll have some opening problems which we will do in class together, and then we will and then you'll have your classwork to work on. Okay, in the meantime, so here are some opening problems, and I'd like to do just one of them actually, as opposed to just leaving them for class, just to remind us on how to work on the set notation. Okay, so we said that set notation was for figuring out, we would use it to find the domain and the range. Now, the domain, we said, were the x values. So what is going on with our x values on our graph? And the range is referring to what's occurring to the y values in our given graph. So if we just take a quick look at part A here in the question, we have a graph, and if we're looking at the domain, well, the domain means that what I'm doing is I'm looking for the set of all x. So everything I have written out right now with the curly brackets and the x is the set of all x, such that, there's my slash, x. Now when I take a look at my values of the x here, it would seem that the x is going off to negative infinity on one side, to the left, and it's also going up to positive infinity off to the right, in that all the x values seem to be possible. And how do I know that they're possible? Because I do see that there are arrows. So that tells us that x is going in every direction. So when that occurs, I can then just say that the set of all x is such that x is an element of, or belongs to, the real numbers. And what that basically is telling me is that the value of x could be any number, because it is allowed to be any number. Okay? Now, if I'm looking at the range, so the range we are looking at the possible y values, I notice that my y values seem to start at one spot and end at another spot. So I know for sure that my graph is coming up to the point 2. So I know it's going up to 2, and it's getting closer and closer to 0. However, the 0 point, the 0 point though, is never touching. It's actually never touching the 0. The y's are never actually touching the 0. So that I can say that because I'm looking at the range, it's the set of all the y's such that, and now it seems to be that our values of the y are between 0 and 2. They never go below the x-axis, so they never go below 0. So that I could say, well, the value of y has to be less than or equal to 2. I know it's equal to 2 because it's touching 2. But I have to say, though, that it's got to be greater than 0 and not equal to it. It can't be equal to 0 because it's never crossing the line. It's never crossing the x-axis. So having done the set notation here, I've got that for the range. I know that my y values of the y are going to be less than or equal to 2, but they need to be greater than 0. Okay, so we'll leave the next question for class, and we'll move on to the next. So in the next part, now we're still on section 14a, but instead of looking at just set notation, we're going to look at a new type of notation. And the new type of notation is called interval notation. Now, in interval notation, we tend to use square brackets or round brackets, or we could have a combination of square and round, or round and square. Now, if I place square brackets, it means that I am including a certain number, or a value, and if I place round brackets, that means that I'm not including a number or a value. And we can use obviously a combination of those parentheses in the same domain or the range, depending on what our graph looks like. Okay, so let's use interval notation and do these three examples. So the first one, it would appear that I have a point that starts off at -4 and 4. Okay, so there's one point there, and then I have another one that goes to 4 and 4. So those are my 2 points. Now, when I look at my values of the domain, okay, so let's start doing the domain with set notation. So we're just going to do set notation first. So if I had to do the set notation here of the domain, I would say the domain is equal to, all the set of x such that, well, x is an element of R. We know that x is an element of R because it belongs to all the real numbers. We have a solid line going through here, which means that every number is included, all rational, irrational numbers. Now, when I take a look at my domain, it would seem that my domain is going from -4 up to 4. Now, so I know that x is going to have to be less than or equal to 4, and I see that because it's going up to a maximum of 4, and it's including 4 because I have a closed or colored in circle. But on the other side, if I look over on the other side here on the left, my circle now is an open circle, which means it's not colored in, and therefore it means I'm not including the number -4. And therefore, if I'm not including the number 4, then I will not have an equal sign. So unlike the right-hand side, I have less than or equal to. The other side, I just have x is greater than -4. So that would be my domain. Now, if I were looking at the range, okay, actually, let's do the domain now using using interval notation. Now, when we're using interval notation, what we actually end up doing is we actually are looking, again, from left to right and from bottom up, just like we did with set notation. The only difference being that now, instead of using curly brackets, we're going to be using square brackets or round brackets or a combination of the two. Now, because the -4 for the domain is not included, then I will put a round bracket in the interval notation. So let me just write interval notation. So I will write the domain is equal to, and I will have a round bracket. And it starts at -4. And now, to show that it's in between -4 and 4, all I have to do is put a comma in between, and then I just go to 4. So I am not including -4, but I'm going from -4 to 4. And then because that 4 here is included, because it's colored in, the dot, then I will place a square bracket. So that would be my interval notation for the domain. Now, if I do the interval notation for the range, again, I start from bottom up. I see it starts at 0, and it includes 0, and goes all the way up to 4. Now, because going all the way up to 4, I have one that has 4 not included, but the other value of y, the 4, is included, okay? Then, what I'm going to have to do is, because one is included and the other one isn't included, I'm going to have to include it, so that I can say that the range starts from 0 included all the way to 4 also included, because I'm going to have to include it because one of them is included. So that would be my interval notation for the range. Now, if I were to do the set notation, just to be consistent, if I were to do the set notation of the range, just to finish it off, okay, for the range, then I would say y is such that y is an element of the real numbers, and then I would say that it goes from 0 goes to y all the way to 4, and that's all included. Okay, so that's the other way of expressing this. Y is an element of R. So there's my domain, and there is my range here with the set notation, and then here we have the interval notation with the two of them. So there's our interval notation in between. Okay, so if we look at the next example, so let's just do the next example. Let's do the next example with, let's do the next example B, whereby we are just using interval notation. Okay, so interval notation only. So again, I'm going to be looking at my graph, and if I'm looking at the domain, I'm looking at my possible values of the x, and it seems that my values of the x, we go from -1, 0 to 5 and 4. So it would seem that my values of the x are going from -1 all the way to 5. And I'm including both of those points, and any numbers outside of that are not included. So the domain is going to be, domain is a set of all numbers such that x is an element of R, where my value of the x has to be less than or equal to 5, but it has to be greater than or equal to -1, and that covers that. And if I have to, I just did this, by the way, not in interval notation, but I did it in set notation. I apologize. So let me just do it in set notation. Okay, so in set notation it was like this. And then our range is going to be y is such that y is an element of R. And my values of the y, they start at 0. So it has to be greater than or equal to 0 or less than or equal to 4. Okay, now, if we now want to do this in interval notation, which is the scope of this lesson, okay, then in interval notation, I start with the domain, and I will say, well, I am including the -1, so it'll go from -1 all the way to 5, and the bracket is going to be square. It'll be closed because we're looking at including. And then for the range, we will have, again, it'll be a closed bracket from starting from 0 going all the way up to 4. And that would be that. Okay, if we take a look at the next one, let's look at C. In part C, so we're just going to do interval notation this time, as opposed to what I said a few minutes ago. So in this problem with interval notation, I see that my values of the x, now we have a parabola here, and our values of the x seem to be going on to infinity in all directions. In that, my graph could be getting, and this is the tricky part, because our graph, if you take a look at it, the graph gets larger and larger. It increases along the x, although it doesn't look like it's increasing. It looks like it's going up, but it's not, because essentially the graph just gets wider and wider as we move along. Okay, so our values of the x are also increasing or decreasing. Okay, so that I can say that for the domain, I can say that because the values of the x seem to be going in every direction, I will have an open bracket, or rather a round bracket, going from -infinity all the way to infinity, because it's going in every direction. Now keep in mind that any time you are dealing with infinity or negative infinity, there will always be round brackets, because infinity can't be stopped. Okay, you can't include infinity. Okay, so if I now look at the range, well, the range seems to start at 0, and then it seems to go on forever up, going above the x-axis, so that our range would go from 0, which is included, all the way to positive infinity, which is not included. Okay? All right. So we have a few more examples here. Let's take a look at D, and maybe we'll go on to F. Okay, we'll do D, and then we'll do F. All right, so for question D, so let's take a look at what we've got. Question D, I am assuming, is going on to infinity in both directions. I have arrows here, okay, for both of them. So if I have to do this problem, now let's do this one in set notation first. So if I had to do this in set notation and I had to do the domain of that, it would be x is such that x is an element of R. Now, I can take a look and see that all the values that seem to occur for the values of x are from -2 and smaller numbers, and then 2 to larger numbers. So that I could say that x must be less than or equal to -2, sorry. I would say x has to be less than or equal to -2, or x has to be greater than 2. So that would be my set notation for that. Oops. I'm just going to try to grab this part to put a little closer in. Okay, so that would be the first one. And if I had to do the range in set notation, again, the set notation, it's all the values of y such that y is an element of R, where, so our values of the y seem to, again, they seem to be at 3. So the highest point here is it's found at -3 and 3. So it seems to be at 3 and below, or 4 and above, so that y has to be less than or equal to 3, or y has to be greater than 4. All right, now setting this up in interval notation makes it might be a little bit easier to do interval notation here. So let's do the interval. Okay, so the domain is going to be, so starting from the left moving towards the right, I'll start off with an open bracket or a round bracket, negative infinity, all the way to the number 2, negative infinity all the way to the number -2, where it is included. And then I'm going to do a union with the next one being 2 not included, going all the way to infinity, and that's not included. Again, we have a round bracket placed on that. So this is telling me that all the numbers that go from negative infinity to -2 are included, so up to -2, and then there's a jump between -2 and 2. See, there's no 0, there's no 1, -1, 0, 1, okay? So then if I have to do the range now, the range will be from, starting from the bottom, it would go from negative infinity up to 3, where 3 is included, and a union with 4, and that's going to be a square bracket because it's included, 4 all the way to infinity, where we have a round bracket. Okay, so let's do one more here on interval notation with f, so that I can do interval notation. Okay, with f, so we'll say domain is equal to, well, the domain seems to be going in all directions, so it's because I have arrows at the end of this. So it's going into all directions, and therefore I can say that its domain is going from negative infinity to infinity. My range, on the other hand, I see that it seems to be oscillating between the numbers 1 and -1. Okay, so it's going between 1 and -1 here. So that I can say, and it's including those numbers, so the range is going from -1 to 1, and that is all included. So we have square brackets all the way through. Okay, we have other ones. Let's try doing, for example, I'm going to leave G and H for the moment. Okay, I'm going to leave G and H for the moment, and I'll just make sure that it is understood here that this is ending here and that is ending there, so that and H, so that you can be clear on where things are. Now, on the next one, on I. Now, sometimes one of the things that needs to be discussed or needs to be looked at is that very often what happens is that because there are certain values that something isn't allowed to be, rather than writing down what it is allowed to be, what the domain is allowed to be, sometimes it's easier to say what the domain is not allowed to be. So when I take a look at this, when I take a look at I have here the graph that starts at -6. So I'm looking at the left-hand side of this graph that's going downwards, okay? And I see that it's getting closer and closer to 0, the graph here at the x-axis, but it's never crossing it. And I'm seeing the same thing occurring, okay, also on the other side, where I have the graph crossing here, getting closer and closer to 0, but never crossing it. Okay, so when I am looking at my range in this case, so I'm looking at my values of the y, okay, it would appear that the values of the y can be everything except one number, and that would be what number? It would be the value of y equaling 0, because it never touches the 0 line. See, the graph never crosses over, okay, to the other side. So it gets closer and closer to the y-axis but never touches it. So what I can actually do is I can say, if I do this with set notation, it might be a little bit easier. I can say the range is equal to so that I have y is such that y is not going to be equal to 0, which implies that, that it can be every number other than 0. And then if I were to look at my domain, well, it would seem that if I look at my x values, it seems to be at x equaling 1, it's getting closer and closer to 1, the graphs are getting closer and closer to 1, but they never actually touch 1. Therefore, my domain is going to be x is such that x is not equal to, will never be equal to 1. So instead of writing down what y or x are allowed to be, we're writing down the restrictions, or what they are not allowed to be. Now that would be in set notation. If we do this in interval notation, okay, so the domain is going to go from negative infinity, not included, all the way to 1, again not included, and then union from 1, not included, all the way to infinity. So notice that we're not including the 1 in there. For the range, I got a class in here. For the range, we go from negative infinity all the way to 0, union from 0 to infinity. Okay. So the next two questions I'll insert in the next two questions I will insert in the play posit for you to complete on your own, and I expect you to do in class interval notation, still exercise 14A, numbers 2 and 3, but use interval notation instead of using set notation. That's